So I'm going to go ahead and welcome you to the April 4th Rotary Club of Ames. If you are able, please stand for the Pledge of Allegiance. I pledge of allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. Let's please remain standing for individuals or families we'd like to keep in our thoughts. Karen and I didn't have anyone written down or know of anyone. Is there anyone in our Rotary family that has someone that we should be keeping in our thoughts and hearts? If not, let's just take a moment to just bask in our own thoughts and memories. Thank you. Well, we really appreciate the guests and visiting Rotarians hopping online. Thanks for tuning in. And I think if John is handy, I will let him take it away.
Thanks, Kelsey. Yes, so welcome to our guests and visitors. Welcome to you from Ames Rotary, Nevada, London, or Paris, from far off lands or the USA. We're glad that you are here today. Come back again whenever you're near. Join us and then we'll make it clear. Around the world you will always be. Welcome at Rotary.
Thank you, John. Stay close to your microphone because it is the first meeting of the month and we've got birthdays and anniversaries and Rotary anniversaries. So I think if we just sing happy birthday, that might be enough. And then we'll just recognize some of those anniversaries. So happy birthday.
Leading us, Kelsey, and happy birthday?
What?
You can lead us. Go ahead.
Happy. No, are you? I think you're trying to recruit me. You're trying to test my voice to see if I'm worthy.
Here, I'll take it away. Happy
Thank
birthday to you. Happy birthday to you. Happy birthday, dear Rotarians. Happy birthday to you.
Thank you. We have some anniversaries this month. Happy anniversary to those Rotarians. Thanks for being with us. We have some Rotary anniversaries. No matter if you've been in the club for 55 years or 1 year, you matter to us. So thank you so much for being in the club involved. We really appreciate you. Yes, the community grant applications are available. If you have any questions about those, just let us know, but they are available. And the deadline for those are Monday, May 2nd. Is that, the big one. Next Monday, Kent has secured Senator Ernst for next Monday. Doors will open at 11:30. We're gonna try and get her on the mic as soon as possible because we know there's probably gonna be a lot of questions. So we will start promptly at noon, or maybe like a smidge before if it's getting a little rowdy. But yeah, if you have any questions, send us an email. But we are looking forward to her remarks and we will see her on Monday. That being said, I will introduce Kent up, or I'll invite Kent up to introduce our speaker.
Thank you, Kelsey. And one thing about when Senator Ernst is here, she has designated the Rotary Club of Ames as the priority for any questions and answers. There may be press available there, but they're not going to be permitted to question her at that time. You guys are the priority. So I just really appreciate them willing to do that for us. However, today we have a real exciting speaker because he impacts our life indirectly every day with this thing called weather. Dr. William Gallis has been a professor of meteorology at Iowa State University for 27 years. He's currently serves as its professor in charge and as associate chair of the Department of Geological and Atmospheric Sciences. Bill's research focuses on improved understanding and forecasting of smaller scale weather phenomena, such as thunderstorms. We don't have any of those. Severe weather. We don't have any of that. Tornadoes, maybe one or two, and winds within wind farms. He has published over 110 papers on those topics in scientific journals and has received the College of Liberal Arts and Sciences Outstanding Achievement in Research Award. Dr. Gallus teaches courses related to weather forecasting and has received the ISU Foundation Award for Outstanding Achievement in Teaching and as a College of Liberal Arts and Resource Master Teacher. He's given hundreds of interviews to print and television media and a similar number of talks to community groups such as the Rotary Club of Ames and to schools, usually on tornadoes. Dr. Gallus, with no exception, will look forward to your presentation today. Thank you, Bill.
Oh, I'd like to thank all of you for being here and to Kent for inviting me. Let me bring up my presentation. So I kind of used what Kent told me he thought would be a good thing to focus on to develop the talk that I'll give you today, which will be on the December 15th, 2021 derecho and tornado outbreak. And then I'll close a little bit of background into what are some recent developments in severe weather research. So, most of you probably remember the December 15 outbreak. I've seen people posting on social media saying they never hope to see something like that again. I think mostly just because it was rather scary during the day, anticipating what was going to happen. This event was truly remarkable. I've heard people say it might be one of the most bizarre weather events to happen in terms of how unusual it was. It was the first time that a derecho was ever observed anywhere in the United States in December. So a derecho, we're all very familiar with that in Iowa. It's basically a thunderstorm system that produces extremely damaging wind over a very large area. It has to extend for about 400 miles long, at least 60 miles wide, last for 6 hours. That had never happened in December. And if you had asked anybody in meteorology, what state was probably going to be the first state to have a derecho in December, probably they would have said Texas or Florida or Louisiana. Certainly not a place that's usually buried in snow by mid-December like Iowa. The December 15th event was also interesting because we set a record for the hottest it had ever been in the month of December in Iowa. A few stations hit 76. Here in Ames, I think we were 74. By the time the event ended, 63 tornadoes had hit Iowa. Now, the previous record for a single day was only 35, so we almost doubled the previous record. And if you took all of the prior Decembers combined in Iowa, there were only a total of 5 tornadoes, and they were all in southeast Iowa. In addition, what made this event very unusual is that the tornadoes moved 2 to 3 times as fast as usual. Some of the tornadoes were moving along at 100 to 110 miles per hour when they normally move about 30 miles per hour, which makes it extra hard to warn the public. So how did this happen? What took place in mid-December to allow this incredibly strange weather event to happen? So what we really need to do is go back and think about what are the ingredients for derechos and tornadoes. So both of these require a thunderstorm to be present. And to get a thunderstorm, there are 3 ingredients that must be present in the atmosphere. The first one is something that we call instability. That means that it's really warm and humid at low levels down near the ground, and it becomes much colder as you go higher up in the atmosphere. So when you have instability, it allows air to rise upwards in the atmosphere like a hot air balloon because it finds itself being warmer than the air around it. In addition, we need moisture. So I don't know how many of you know this, but there's always moisture in the air, but as long as it is vapor, which is gas, you cannot see it. The moment that the water vapor condenses into cloud and turns into liquid water, it gives off heat. So it's like we're walking around all the time in an atmosphere full of dynamite. So this is like adding fuel to your hot air balloon, which will help the air to go up even faster. And then finally, usually you need something in the beginning to start the hot air balloon upward, to start the air rising. And typically that is something like a cold or a warm front. So you can see what happens from this picture I took on a storm chase in Western Nebraska. The part of the thunderstorm where the air is rising rapidly like a hot air balloon is this feature where I put a white arrow. It looks kind of like a giant's boot coming down from the sky. You can always tell when you look at clouds if the air is rising in the cloud, because if you can see the outline of the cloud very clearly and it looks dramatic, that means the air is going up. When the air is going down, typically because you have rain falling, it will look more like the right side of my picture where things just become this smeared out sort of sheet of gray. So in this example, we have a thunderstorm because we had those three ingredients. Now, for a derecho, there's a few extra ingredients that need to be in place. Usually what you need is especially large amounts of instability, like we get on hot summer days, like the morning of August 10th in 2020. Generally, the winds a few miles up in the sky are stronger than normal, but they don't really change the direction a whole lot from what is happening down near the ground when you have a derecho. And in addition, there's usually some dry air a mile or two up in the sky, which means that when the rain and the thunderstorm is falling down through that dry air, a lot of it will evaporate. So in the old days, I know in the desert Southwest, my wife is from Las Vegas, they often cooled things, not with an air conditioner, but with a swamp cooler. And that operates on the same idea that if you're putting mist into the air, you evaporate the water, and that makes the air colder and heavier. So in a thunderstorm, if you have that dry air present, you create this heavy cold air that will rush down to the ground and accelerate. So that was what took place for our infamous August derecho in 2020. It produced winds as strong as 140 miles an hour, especially in the Cedar Rapids area, where you see this damage to a house that looks, or maybe this is an apartment building actually, the damage looks similar to what you would see in a tornado. And I'm going to play a 2-minute long YouTube clip for you, just in case you forgot how horrible it was to watch the winds come through in the derecho. I believe this is the best video I saw from the event to display the power of the wind in the derecho. And this was taken, I think, at a country club at the golf course in Cedar Rapids. So let me bring that up. And we might have to skip through an ad at the start. We'll look here. If so, it would just be for 5 seconds.
Drinking water before bed burns 46 pounds in 2 weeks.
Almost ready.
If you are struggling to lose weight and you're over 20.
So one thing you'll notice in the derecho is that the winds just do not stop. They keep coming in wave after wave. And just when you think the worst is past, it seems like it gets even stronger. So I think you can tell from that video, you know, it's a wonder there weren't more people killed here in Iowa when that event happened. And you had to be thinking, what in the world is going on? In Cedar Rapids, those winds lasted for almost an hour. And it's also easy to tell just from that golf course how 65% of the entire tree canopy in Cedar Rapids was brought down, was destroyed. So now you know the ingredients that we look for typical derechos. For tornadoes, which we also had, of course, many on that day in December, the extra ingredients are wind shear. So we're actually getting a change in the wind direction and the wind speed as we go up in the atmosphere. Remember, in a derecho, the wind speed tends to change, but the direction not so much. Well, how this plays a role in getting a tornado can be seen in these pictures. Although the easiest way to understand how tornadoes form is to take a pen or a pencil. If you have it, and lay it in one of your hands, then take your other hand and have your other hand slide along, hitting the top of the pen or pencil. So you'll see that when your hands are behaving differently, that's like having the winds behave differently, and it creates a rolling motion to the air, which is shown in the top picture. Now, if you have your pen or pencil rolling, remember that in a thunderstorm, you have this hot air balloon effect. The air is going up. So if you're coordinated and keep your pen or pencil rolling, but tilt one end of your pen or pencil upward, so that's imagining that that end of your pen or pencil is in the thunderstorm. As you continue rolling, you will see that eventually you develop the kind of spin you see in a tornado. And at that point, you know, you can look at the lower figure, and this explains how the thunderstorm can start spinning more quickly to create the tornado. It's the same effect when an ice skater wants to have a dramatic ending to their performance. If they want to spin really fast, they move their arms inward, and that increases the spin. In a thunderstorm, as the air is going up, the air must also be coming in to replace it at low levels, which is just like the ice skater bringing her arms in. So now we can see wind shear is important because it causes the air to roll. If the air is rolling and a thunderstorm forms, the thunderstorm can tilt the rolling into a vertical spin that can be accelerated. Now we know that wind shear leads to spinning storms, but not a lot of these produce tornadoes, which you can probably think back every time you've been in a tornado warning or heard the sirens blow. I would guess the vast majority of those times you never saw the tornado. And that's because it's really hard to predict excuse me, exactly which storms are going to create the tornadoes. It appears that there are small scale features within the thunderstorms themselves, such as rivers of air flowing downward, such as the rear flank downdraft, that are actually needed. And the reason for this is if you go back to your rolling pen or pencil, realize a downdraft can take that rolling motion and tilt it down to the ground just as well as an updraft. And downdrafts can actually hit the ground with a lot of speed. Updrafts can't because air cannot come up from the ground. So we believe downdrafts play an important role. This is a picture I took in Wyoming on a storm chase. This is a very powerful rear flank downdraft picking up lots of dirt from the farmers' fields. The winds were blowing over 100 miles per hour. How do I know that this is from a downdraft? Well, when air sinks in the atmosphere, it warms up and dries out. So it eats away cloud. So if you're getting rid of some of the cloud, more sunlight is able to come down through. So in my picture, you probably notice the really black clouds, but in the upper left, where I have the pink arrows coming down, the sky gets very bright white. And that is because light is able to be coming down in that area of the downdraft. When the sinking air hits the ground, it's forced to spread out. And so this is typically an area where you will see a tornado develop. And shortly after I took this picture, a tornado did form just behind the dirt. So if we go back to my original picture of the thunderstorm, we can see all of the factors that are playing a role when we get a tornado. We have the air rising in the main part of the thunderstorm. When rain falls, it cools the air and helps drag the air downward. So there is a downdraft on the right side. And in addition, we have this rear flank downdraft that almost always seems to be present around the time you start to get a tornado, as in this picture. The final arrow I have on here in yellow is supposed to show you that we know there must be wind shear on this day. How do we know there's wind shear? Well, the giant's boot, where the air is rising, is where you create all the raindrops and snowflakes, but yet it's falling off on the right side of the picture as rain. So what is happening is we know the winds up high must be stronger and blowing it off to the right because it is falling to the right of where the tornado is trying to touch down. We've learned that not all downdrafts lead to tornadoes. A lot of crazy weather fanatics have gone out, students with instruments on their cars in the vicinity of tornadoes to take the temperature of the air. And what we find in this picture, the top two images are from events where we end up with strong tornadoes that last a long time. And the light gray color means that the temperatures were only a little bit cooler near the tornado than they were out ahead of the storm. In the bottom pictures, the storms looked exactly the same as the top pictures, but we never got a tornado, or we only got a very brief, weak tornado. And in those cases, we have found that the air near the tornado was actually much colder than the air out in front. And it seems that the colder the air, the heavier it is, and the harder it is for the thunderstorm to suck it back up, which is needed to really get the air spinning. Now, normally, instability is really lacking in Iowa in winter because it is not very warm and humid, but we almost always have lots of wind shear in winter. So on December 15th, we had abnormally warm and humid air that came abnormally far north to give us the instability that we needed. And there also was an exceptionally powerful storm system, so that the wind shear was really off the scales. You may have heard TV people around that date in December, you're talking about how unusual the storm was because the winds were so strong at all levels of the atmosphere. So the result on December 15th were lots of reports of tornadoes and storm damage. So on this map, the red dots are tornadoes. At this time, there were 72 that had been identified. In the end, it turns out the final count was 118 tornadoes on December 15th. And the blue dots and the black squares are the reports of severe wind. And so this event also became famous for having more hurricane force wind gusts from a derecho than any other derecho in history. I think I'll skip through some of the weather maps that I had here valid at the time and just point out it really was an event that made it pretty obvious the morning of December 15th that we were going to be in trouble in Iowa. In fact, if you look at the official weather forecast from the Storm Prediction Center on that morning, you will see in the upper left, they had part of Iowa in red in moderate risk. Moderate is level 4 of a 5-level scale. And this was the highest risk that we had in Iowa all last year. In addition, in the lower left, there is a yellow area for 10% chance of a tornado and a black line. The black line indicated a good threat of strong tornadoes, and there were 33 Ef5, which is a strong type of tornado on that day. And finally, the lower right, the Storm Prediction Center used purple, which is extremely rare, or pinkish purple here, a 45% chance of damaging wind, again, with the black stippling indicating the threat of hurricane force wind gusts. So this event was crazy. It was off the scales, but it actually was rather well forecasted. Well, just for a little bit of a treat, I'm not sure how many of you have ever seen this video. Since Iowa had so many tornadoes on this day in December 15th, I wanted to show you the first video that was ever taken inside a tornado because it was taken in Iowa. It was a good roughly 15 years ago near the small town of Webb, Iowa, out near Storm Lake. This video was provided to me by a friend, Tim Samaras, who was one of the most famous tornado chasers in the country. Tim sadly was killed by a tornado in 2013, but he had given me this video. So what you will see is this is taken from an instrument probe that had 7 cameras in it, six of them looking out sideways. So you had a 360-degree view and one pointing straight up. So in the beginning, there will be footage from 3 different cameras strung together. So you can pretty much see the tornado as it moves along and almost almost hits the instrument probe directly, then we're going to go back and look at the first two probes and allow the tornado to actually pass completely over them. So you'll also get to hear what it sounds like if you're in a tornado and what it might look like if you're in the countryside. So the tornado is approaching the probe from the west. Now we'll swing and look to the northwest as it is mostly passing by just to the northwest. And then finally, we're looking north and we'll watch it start to move away. And then finally to the northeast. So now we'll go back to the camera that was facing west initially, and this time we'll let it run until the tornado is overhead. So one thing you might notice, if you've never heard a tornado, you might have heard people say it sounds like a freight train. Others of us, including me, describe it more like a waterfall in the distance. So then you'll notice the tornado picks up lots of dirt from the dirt road. And so the mud ends up covering the camera until the rain is able to come back and wash some of it off. Now we're going to point to the northwest toward a farm. And I want you to watch the trees. The trees are never hit by the tornado, but right about now, you're going to start seeing them fall toward the tornado as the winds become very strong, approaching the tornado. And then there's going to be an object flies by in the video very, very quickly, but most people can't see it. So he slows down the video frame by frame. And when he does that, you'll notice that a 2-ton corn bin is rolled along, and he calculated that it was moving at 90 miles per hour as it came through in the video here. So let me move on. Oops, wrong way. Now here in Ames, our most famous close encounter with a tornado was also at an unusual time of year, not quite as weird as December 15th, but this was November 12, 2005. And many of you, if you're Iowa State football fans, probably remember this event. The tornado approached the city of Ames an hour before kickoff of the game between the Cyclones and the Colorado Buffalo. The tornado did destroy a home on the very west edge of town and caused a lot of damage just south of Gilbert. But I like showing this picture because the Colorado Buffalo coach ended up saying, I thought we had a pretty good mascot, but when we showed up at Iowa State and they had a real tornado, that's the real deal. So I was happy he had a good sense of humor. Iowa State ended up upsetting the Buffalo, and I think it was partly because we really had them on the ropes. They were rather terrified by what happened just before the game. So that's really the overview I wanted to give you about the December 15th event and teach you a little bit about how we get tornadoes and derechos. And I wanted to end then talking to you a little bit about what are the latest developments in severe weather research and forecasting, which is probably important that we're constantly developing better ways to forecast them, since Mother Nature seems to be drunk at the moment and is causing lots of very abnormal timing for getting tornadoes. So one of the new developments is that the National Weather Service has decided that all of the American forecasting models should use the same, it should all be unified into one single model. This is what most of the countries in Europe have done. And that has allowed them to make better progress at creating a better forecast model. In the US right now, there are at least 3 different forecast models used by the National Weather Service. This model is called the Ef5 for finite volume on a cubed sphere. So it's a really complex idea. And testing is ongoing as to how it will do for severe thunderstorms. So I want to show you some testing I myself had done of the August 20 derecho event. So in the upper left is a picture from radar. And this is the moment where this nasty thunderstorm system was destroying all of the trees in Cedar Rapids. And we ran the model on 3 different grids. So in the upper right is a very coarse grid that you might use for climate modeling. And this is an 18-hour forecast, and it showed a really scary looking thunderstorm system in Iowa. In the lower left, a 13-kilometer version of the model, which again showed a very powerful storm system that matched really well with what ended up happening on radar. But then in the lower right, when we go down to a very fine grid, this is normally what we run to forecast thunderstorms. We see that something totally different happened, and it wasn't different in a good way. In this version of the model, it didn't show a whole lot happening in Iowa. So you might remember back to the August derecho that it wasn't forecast very well. We didn't really know it was coming until like 2 hours beforehand here in Ames. So one of the reasons many models did terrible at forecasting this derecho is during the night before, when in the radar in the upper left, if you look at Iowa on the right side of the picture, nothing was really happening on that Sunday night, but the 3-kilometer version of the model had lots of thunderstorms blowing up. So that ended up using up all the energy, so nothing much could happen the next day. Well, I want to show you an interesting thing we found in this 3-kilometer version of the model. So I already showed you on the left, the one version did a terrible job. Well, there is a piece of code that we sometimes call a parameterization. It's like a black box that we normally use on coarse grids to help the model show thunderstorms. We should not have to use it on a 3-kilometer grid. But for the derecho, when I turned it on, it turns out on the right side, you see that the forecast changed drastically, and it became an excellent forecast, showing a very intense thunderstorm system moving across Iowa. It was just a little bit further south than what was observed. But one of the remarkable things in this model simulation is if you go on the left picture or the right picture, this would be, the left is 11 a.m. in the forecast from the model. The right picture would be at noon. The colors are the temperature field. And so there's a drastic change when the thunderstorm goes through from the greens to the dark blues and purples. And this shows the temperature dropping from the low 80s Fahrenheit into the mid 50s. Now, I don't know how many of you were in Ames when this derecho went through in August and who went outside right away as soon as it appeared to be safe to do so. The remarkable thing for me is I walked out my front door to go look at the damage, and I instantly turned around, went back in the house and grabbed a coat. I looked at my thermometer and did a double take because I thought it was probably like 67 degrees. It was 57. So this new model that we'll be using correctly showed this huge drop in temperature, and it showed that the winds were blowing at about 80 miles per hour near the ground, gusting to 115 in the thunderstorm. So this is a forecast model that ran at 7 p.m. Sunday night, so the night before the derecho. So it's kind of exciting that we might be able to get better forecasts like this. And by later in the afternoon, when the real storm system in the upper center part of my slide was plowing into Chicago, this version of the model in the lower right did a very good job of showing the thunderstorm line getting longer and longer and well on its way to Chicago. One of the other new developments in severe weather research is that there's work on a new type of weather radar. And this is called phased array radar. So this is a type of radar that has been used on ships for a long time. This would allow us to get radar data of storms every few seconds. Right now, we have to wait a few minutes to get a new radar scan. Tornadoes develop and change very rapidly. So having something that scans every few seconds could really help us give better warnings to people. So we would now find things that look like the upper left, the phased array radar, instead of what we now use with our NEXRAD radars at the Weather Service and our TV stations in the lower right. And then finally, the other thing I would say that is ongoing that's kind of exciting is research on how climate change might affect severe weather. So you all know now the ingredients for derechos. And so if we understand what is happening with our climate, we might be able to take a stab at knowing what's going to happen to derechos in the future. So the warming and increasing humidity in the lower atmosphere should actually increase this energy, this instability, which might help increase derechos. But at the same time, with global warming, it's actually the North Pole and the South Pole that are warming up the fastest. So this decreases the contrast between places like Alaska and Florida. This decreased contrast generally weakens the jet stream. It weakens the main flow on Earth, which should actually make it harder for derechos to happen. But so there's two things conflicting. But number three, which might be the deal breaker, is the warmer air near the ground could increase the winds that happen when this cold air descends toward the ground, because there will be a bigger temperature contrast. So the most likely scenario is that you won't really see an increase in the number of derechos, but the strongest ones might become a little stronger when the right wind conditions do happen up high in the atmosphere. And derecho season may get longer, because the fact that the Earth is becoming warmer will allow us to have more instability happening earlier in the spring and later in the fall. And this obviously was demonstrated by having a derecho in Iowa in December. Now for tornadoes, we've studied them in more detail than we have derechos, and we know again, the greater instability is helpful for tornadoes, but the weaker winds are not helpful. But people have done research showing that the atmosphere will still be able to produce days when you can create strong wind shear. And because the instability, the energy will be greater, tornado outbreak days will likely become more intense with more big tornadoes and stronger tornadoes. So the most likely end scenario is there will actually be fewer days each year with tornadoes happening, but they'll become more concentrated on the fewer number of days, which means we'll have worse outbreak days, days where at least 6 tornadoes happen all at once. The strongest tornadoes may get somewhat stronger. And again, we believe the location and timing could shift to places further north and earlier in the spring, later in the fall, with more during winter. Once again, not only was this demonstrated by the December 15th outbreak here in Iowa, but if you think back just about a month ago, we had an Ef5 tornado near Winterset, Iowa, that tragically killed 6 people there, and another tornado killed 1 in far southern Iowa. This is a picture of the tornado near Winterset. This was the furthest north in the United States that we have ever had a tornado this strong so early in the spring. Also, in recent years, the number of US tornadoes in a given year seems to be getting more variable as the atmosphere gets stuck into particular patterns more often. So a good example is back in 2011, this is when Joplin, Missouri was hit. We had over 700 tornadoes just in the month of April. We smashed the record for the most tornadoes in a month. But then after 2011, we have had many years that have been extremely quiet for tornadoes. So it seems that it would get harder to tell how many tornadoes might happen in a given year. This is a graph of all tornadoes that are rated at least EF1. And the most recent years are on the right. We're missing the last couple, but they ended up plunging back down. So there seems to be a lot more bouncing up and down between individual years in the most recent part of the graph. So to wrap up my talk today, I'll just point out for many years, we have known why some thunderstorms spin, and we can predict those days fairly well. It is more challenging to predict which spinning storms will produce tornadoes, and also which days are going to result in storms that produce derechos. And it is not easy to determine how climate change will affect these features because of the conflicting trends. Probably the most certain things are that both of these derechos and tornadoes will be able to happen earlier and later in the year due to the increasing warmth and occur further north than before. Also, the strongest ones will probably become a little stronger than now, but the total numbers may not change much or could possibly even decrease a little. And with that, I would like to thank you all, and I am willing to take any questions you might have as long as you all have time. And I'll stop sharing so I can see everybody.
Bill, I had never heard the term derecho until the storm in August, but in what you're sharing with us, we've had them in the past. What pronounced, why did that all of a sudden become part of our vocabulary?
You know, I was surprised because I heard the same thing. Everybody that I would bump into after the August derecho was asking me, is this a new term? And I've been teaching now for almost 30 years, and I've always taught about derechos. It was actually a person from Iowa, a professor at the University of Iowa in the late 1800s, was the one who wrote down that we should call these type of storms derechos. You know, I don't know why. I think, well, one thing is this derecho impacted more people than we'd ever seen in Iowa at one time. And so I think that's how most of us in Iowa, you know, that's the first time we really remember hearing that term. There was another infamous, really strong derecho in 1998 that went through Des Moines and continued all along I-80 the whole way into Illinois. And I know people back then talked about that being a derecho, but I think it was more those of us in central Iowa, we had avoided, you know, we basically had avoided a strong derecho for a long time. And I think that's the main reason we had not heard the term before.
And the video that you had received showing, you know, the actual tornado and how strong of a tornado was that one?
That one was rated Ef5, so it was a very intense tornado.
Have we ever had an Ef5?
In Iowa, yes.
Yeah.
So the most recent Ef5 we had in Iowa was Parkersburg, and that was in 2008. Before that, you have to go the whole way back to 1976. And if I mention that date, June of 1976, I bet somebody in the Rotary Club probably knows which Ef5, what town was hit by that Ef5 tornado, because it was very close to Ames.
Jordan.
Jordan. Ankeny has had several Ef4s that took place in the 70s, but the Ef5 Jordan tornado, about halfway between Boone and Ames, was really, you know, until Parkersburg happened, that had been the most recent Ef5. And I was just at a severe weather conference this weekend, and we were talking about in 1968, so not too long before Jordan, in May, we had 2 Ef5 tornadoes on the same day in Iowa. One hit Charles City and one hit Owine. So it turns out one of our former gastroenterologist here in McFarland Clinic in Ames, John Fleming, actually was a child in Charles City at the time. He ended up getting his bachelor's degree in meteorology because of that event, and then used his meteorology degree to go to med school and become, you know, a gastroenterologist. So he's our most unusual alum. I'm curious, how many of you have actually seen a tornado? Anybody? Okay, I see Karen has.
Yeah. Bill, there's a question in chat. Said, what is the typical season for tornadoes and derechos?
So in Iowa, the peak of tornado season in Iowa is actually the last half of May and the first half of June. Our most common months are April, May, and June. So, you know, I would say late March is typically when we have to start worrying about them. And then it sort of lingers into maybe early October normally. Derecho season is more pushed toward the end of summer, so probably from mid-June till early September. So I see another question in chat. What can we do as a society to reduce tornadoes? People have thought about what it might take to, can you disrupt a tornado? Can you reduce a tornado? In general, we scientists would say there's nothing we can really do to reduce tornadoes. But what we can do is reduce the damage that they do and the injuries and the deaths. And that would be to adopt stricter building codes. I've done some work with aerospace engineers. We have a tornado simulator in Howe Hall on campus. And I didn't realize this till I worked with them. In most of the United States, the building code for homes says your home only has to be built to withstand 90-mile-per-hour winds. Almost all tornadoes are stronger than that. If you are in Florida, so if you're in a place that experiences hurricanes, the building codes are much stronger. They require you to be able to withstand winds of, say, about 140 miles per hour. And it involves using things like hurricane straps, not using toe nailing. So actually, instead of just directly nailing your wood frame of your house, for instance, into some foundation, you use bolts with straps and all sorts of apparatus. And I hear that doesn't even really add a whole lot to the cost of a home, but would basically allow your home to withstand the vast majority of tornadoes, which are EF2 or weaker. So as a society, we maybe should be thinking about spending a little bit more money when we build structures so that they will withstand a lot more tornadoes. In addition, when there are mobile home parks, it would be really good if they would have a shelter for the mobile home community. I believe decades ago that used to be rather standard, but we kind of went away from that. And that's kind of unfortunate. Mobile homes can actually be damaged or destroyed enough to kill somebody, even with the weakest kind of tornadoes. Okay, fact check. Is it true that because of the topography of Ames, our community may not be hit directly by a tornado? Someone told me a few weeks ago after the tornadoes that hit southern central Iowa. That is a very good question. One time on a very successful tornado chase where we saw about 10 tornadoes near Waterloo, we celebrated at a diner in Independence afterwards. And I remember the waitress said, "Oh, we're safe in Independence because we're here in this river valley." Well, I'm from Pennsylvania, where river valleys have like a 1,000-foot drop. And I'm thinking, I hate to tell you this, I didn't even notice that this was a river valley. So in Pennsylvania, tornadoes have gone up 1,000-foot mountain ridges, down the other side, back up the other side of the valley and down. Tornadoes have crossed the Rockies, have crossed the Continental Divide. So it is not true. Nothing we have in Iowa would even make a dent in what a tornado wanted to do. So the main reason, if you think, well, downtown Ames or the heart of the city has never been hit, or downtown Des Moines has never been hit, the only reason for that is if you think about it, a city center is a really tiny piece of real estate, and tornadoes are relatively rare events. They're generally pretty small. So you just have to wait about 1,000 years, and then probably both downtown Des Moines and downtown Ames will both have been destroyed. So yeah, there's nothing topographically or with rivers or forest or anything in Iowa that's going to be able to stop a tornado, since we've seen them go over the Rockies and the Appalachians. And right, somebody mentioned about Belmont. Fort Worth, Nashville, these are two cities that have had tornadoes go right through the heart. St. Louis has had tornadoes go right through the heart there. Some have come very close to downtown Chicago. Joplin is about the same size as Ames. And, I remember when I was there a few days after it happened, it was a life-changing event for me. I went down there for research purposes and didn't even think about how appalling it would be to see what we saw. And when I drove back from Joplin, as I was driving through Ames, everywhere I looked, it was as though I was seeing Ames, but I could also see behind it the destruction of what Ames would have looked like Joplin. So, and there's no reason Joplin can't happen in Ames. So there's a very good question here. Does the Pacific water temperatures, whether you're having an El Nino or a La Nina, impact the likelihood and severity of summer storms? It is well known when you have a La Nina like we have right now, that you tend to have worse tornado outbreaks in the southern United States. So I believe 2011, when we had so many tornadoes, that was a La Nina. Here in Iowa, it's been found that we're sort of in a part of the country that we can't benefit from knowing if there's a La Nina or El Nino. It doesn't really change things in a systematic way here. But some of us were a little bit concerned because of the December outbreak and then the March 5 outbreak in Iowa, wondering, if climate change is shifting everything further north, then maybe we're going to start having La Nina years where this part of the country behaves more like Alabama and Mississippi, which are places that really have to be on guard in a La Nina year like this one. In El Nino years, we tend to find springs are a little cold and wet in Iowa, and we don't get as many tornadoes. And it's really hard to say if it will have any impact, say, just on the number of thunderstorms this summer or the number of derechos. But excellent questions. I thank you guys for them. And I see there was an announcement. The Ames City Council has a climate action plan. I was reminded of this when I spoke to the Iowa Women's Club last week. They were interested on whether or not there's things we can do as a community to help make ourselves more resilient to weather disasters. And I pointed out, if you lost trees in the August derecho, a good thing to do is to study a little bit about what are stronger types of trees. There's a lot of ornamental pear trees in town. Those are terrible for many reasons, but they are not strong at all. And so you probably would never want to plant one of those on the west side of your house. Derecho winds would typically come from the west and make it more likely the tree would fall into your house. So then a question, what is the status of bringing the forecasting to the model utilized in Europe? That's a very controversial question. People have sometimes thought maybe we should give up the hundreds of millions of dollars that we spend in the US and just pay the Europeans to be able to use their model. We actually do have access now to a lot of what their model, a lot of their model output. They used to not share it as well as the United States does. The United States keeps starting these efforts that are designed to improve our weather forecast models. They tend to get bogged down in bureaucratic red tape with our government. So it's hard to say for sure, but there are likely to be changes in the next 5 years that should help our models to be much more accurate and probably the skill that the European model has.
Are there any other questions? Yep.
Okay, does global warming have anything? Yeah, so there's the one, does global warming have anything to do with severe weather here? And that kind of fits back, some of the things I tried to point out with what we know about the ingredients, that yes, it will definitely affect severe weather. Exactly how, we don't know, other than the part that makes the most sense is we probably will start having tornadoes earlier in the spring. So I would not be surprised if we start having tornado outbreaks in February within the next 10 years. And maybe December tornadoes will become a little bit more common here in Iowa as well. In fact, so I mentioned being at a severe weather conference this weekend in Des Moines. We invited the mayor of Mayfield, Kentucky. That was one of the town where the candle factory was located. They were hit 5 days before our December 15th outbreak. And, she's showing us unbelievable pictures of the city, totally destroyed. One of the most touching ones was from a drone. They had 6 historic 100-year-old churches in their downtown, all 6 destroyed. But it was a drone video from Christmas Eve. I didn't even think about the fact. So this was 2 weeks before Christmas, and the Presbyterian church totally destroyed. There's the rubble on the one side of the road. The Methodist church totally destroyed on the other side of the street. There's the floodlights. The 2 congregations came together and met outside on the street between the 2 shattered remains of the building. So it really becomes sort of odd when you start pushing your tornadoes into Christmas time.
Absolutely.
You know, I might mention, you might find it interesting from an academic perspective of publishing the results of these tornadoes. I've served on the Iowa Tornado Disaster Investigation Team for many years. And we did investigate the Jordan tornado, et cetera. And so we look for things where we can actually calculate the wind speed. And we found that the Algona tornado, we found the Union 76 sign, you know, it's that big circular sign where the plastic's in that sign. We found that one of those signs did not have the plastic damaged at all whatsoever, but the sign had been bent over 90 degrees to the ground. We took that structural section of that, brought it back to our structural testing lab at Iowa State University, and we tested the strength of the material. We also tested the strength of material from the masonry up in the Algona tornado, and we've done that in a couple other instances as well. And we've actually documented 3 or 4 refereed publications. You know how us academics work in terms of getting credit for publications. We actually got, and we did this up in St. Petersburg in Minnesota as well, where we actually brought the materials back to the structural lab and we tested them. So there's some thoughts for you when you're doing some of these investigations to help us document what we need for the building codes, because you mentioned the building codes.
Right.
We need to put down more things in our building codes to help keep these structures tied down. And you mentioned mobile homes. That's one of the things that's on our chopping block for structural engineers. I do a lot of work on code work for buildings and mobile homes, et cetera. We need tie downs for mobile homes for sure.
Right. In fact, in Joplin, one of the most amazing thing we saw is near the Joplin Hospital, St. John's, parking stops. So those concrete barriers at the end of a parking place that had metal rebar holding them into the ground had been picked up, the metal rebar bent, and they'd been thrown 30 feet away. And so the structural engineer on our team, aerospace/structural engineer, you know, we know the exact shape. We knew they weighed 300 pounds and were at ground level. So he was able to do calculations on that and showed it would require at least 210-mile-per-hour winds to blow those away like that, which was one of the reasons that Joplin was considered an Ef5 tornado. Now, interestingly, when you mentioned the sign, one of the speakers at our conference this weekend is the world's foremost tornado damage expert, Tim Marshall, who's an engineer from Dallas. And I told him after the derecho happened, the Weather Service was implying that Ames did not have particularly strong winds. I live at the very north end of town, and the damage to trees was incredible. And I was like, the wind had to be more than 60 miles an hour. And so I told him near St. Cecilia's Church, there were stop signs that were bent at a 90-degree angle. In addition, there were metal light poles that had been bent at a 90-degree angle. So they're basically parallel to the ground. And I asked him about that, if they're going to try using that as an official way to estimate winds. He said you cannot do that because objects like that have this resonating, natural internal resonating frequency. So what can happen is this, depending on how it chooses to start vibrating, will determine when it will buckle. And so you can't, unlike with a house or a structure, you can't really assign a specific wind speed to it, because I guess in one case, you know, it might snap down at 60, another time it takes 100, kind of like the infamous Tacoma Narrows Bridge that, you know, developed the gallop in the winds out in Washington State and eventually, you know, broke apart. So
yeah, we have a hard time. We have a hard time finding documentary evidence. The Omaha tornado gave us 3 or 4 different results. The Lewis and Clark School is up on the hill. That was like a wind tunnel, went right through that school. So what came out of that was the hallways of schools need to be designed so that there's a perpendicular hallway at each end, so that the hallway itself can't be a wind tunnel going straight on through. We found that the steeple of the church up on top of the hill was designed by the newer code and it stood. It only lost a little bit of facade, but otherwise that steeple
Wow.
stood. And so these newer codes tend to be stronger with respect to the structural aspects.
Right. I'm glad you said that about schools. I was asked years after I came back from Joplin, the Ames High School asked me to be there during a tornado drill and watch what they did with the kids. So I looked, and near the main front, they had a lot of the kids go and sit in the hallway. And it's like basically 5 or 10 feet away from the end of the hallway are these 3-story walls of glass to, like, I don't remember if the cafeteria was there or the atrium or something. And yet, because that's an older school, they actually had some underground rooms they weren't even using. So, you know, I would say, no, you don't want the kids to be in this hallway. I used to say when my kids were young, I would have raced up to Gilbert and yanked them out of school if a tornado was coming, because some of the schools are just long rectangles with glass doors at each end. And in Joplin, I have pictures from the high school of what the hallways looked like, where the kids would have been sheltering if it wasn't a Sunday. And you can see a desk wrapped around the steel beam that used to hold up the hanging ceiling in the hallway. And, you know, lockers are leaning in. Everything is covered with what they called the tornado mud, a combination of ground up insulation and wood and dirt. It would have been a horrible, horrible experience if you were one of those students. And we found this giant Aquafina pot machine at the one doorway. And we assumed it had just moved a couple feet from where it would have been. And a school board member arrived when we were there and said, oh, you see that machine? That used to be at the opposite end of the school. It weighs 800 pounds and it basically would have went the entire length of the hallway. You know, of course, if kids were there, it would have been slamming into the kids along the way. So yes, I hadn't heard people talk much about how sometimes where we put kids in hallways in schools is really not that smart if it's designed that it's just going to become a wind tunnel.
We always say, stay away from long spans.
Yep. We saw numerous churches where on the edge of Joplin, where the entire sanctuary collapsed. It looked like an atomic bomb explosion, but then you would see the education wing and offices, and there was like no damage to that part of the building. So yes, the long spans collapse much easier than, you know, other types of design.
Well, thank you so much for your presentation today. Rotarians, thank you so much for your questions and your dialogue. Max, thanks so much for helping explain that and how you're kind of involved with that. But thank you so much. We really appreciate your time. Kent, thank you so much for getting that scheduled. But as we are kind of a few minutes over, let's go ahead and stand for the 4-way test. Of the things we do and say, is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned? Thank you, everyone, and have a great week.